Hi, so in this video, we're going to be looking at AI5 density, mass, and center of mass. And specifically, we're considering a cone whose base is has radius 5 meters. Here we see a cross section, and whose height is 10 meters. And what we note is that the cone gets increasingly dense as you increase the height, so that the density at height h is 21 over 20 h plus 3 kilograms per cubic meter. So our two questions here is we want to find two integrals, one which will compute the total mass of this cone, and a second integral which will compute the height at which the center of the mass occurs. And so let's begin. So the first thing we note is that we can uh, compute the total mass by essentially taking cross sections of our cone across H, taking the areas of those cross sections against our density at those heights, and then integrating over the possible heights. And so the first thing I want to note here then is, what is this area? So in other words, if I take a height h and I slice here at height h, that's going to be some sort of circular cross section, and I want to know what the radius of that cross section is going to be. So what I know is that when this height is h, the height of the remaining triangle that I cut off, the top part of that, is 10 minus h. What I also know is that this radius, whatever that is, that this triangle and this triangle are similar triangles with the same orientation, and thus we have proportional relationships between our dimensions. So what I know then, for example, is that 5 over 10 is the same as r over 10 minus h. So let me just write that. 5 over 10 is equal to r over 10 minus h, from which I can deduce that r is equal to 10 minus h over 2, right? Since this is 1/2. And so I do now know my radii, and it's 10 minus h. And so with all of that, so armed with all of this information, I am able to compute the total mass of the pyramid. It is going to be the integral over my valid height values. So that goes from 0 to 10. The area of a cross section is pi r squared. And then the density is 21 over 20h plus 3 kilograms per meter cubed. And all of that is going to be with respect to h. And it will have units kilograms. All right. For the second part of this problem, we want to know the height at which the center of mass occurs. And so the first thing we want to note is that the entire thing is weighted in the denominator, I'm going to call this h, by the total mass. So I'm going to just transcribe essentially the total mass that we have already computed. And I'm essentially doing that twice. The only difference being that in the numerator, we weight the cross sections by the height. And by doing this computation, we're essentially computing an average height. So we have h pi 10 minus h over 2 squared, 21 over 20h plus 3 with respect to h. And all of this will have units meters. All right. Thank you very much. I will see you in the next video.